Section 8.2, Arithmetic Sequences and Partial Sums. A sequence whose consecutive terms have a common difference is called an arithmetic sequence. A sequence is arithmetic if the differences between the consecutive terms are the same. So here in our first example, we have 4, 9, 14, 19, and 24. This is considered an arithmetic sequence because if you take the second term and subtract it from the first term, 9 minus 4, you get 5. When you take the 14 minus the 9, the third term minus the second, you get 5. When you take the fourth term and subtract it from the third, you get 5. And when you take the fifth term and subtract it from the fourth, you also get 5. This is called a common difference, and we call it the letter D. And because it's all the same, we say that it is an arithmetic sequence. In example 1, it's asking, are the following arithmetic sequences? So in order for us to determine that, we're going to need to subtract the terms. So my second minus my first, I get 4. When I have 15 minus 11, I also get 4. When I have 19 minus 15, I also get 4. Because I have the same exact common difference, I can say part A is an arithmetic sequence. So I say yes. Now the next one, I have 4 minus 1, which is 3. And then I have 9 minus 4, which is 5. Right away I can see that these two numbers are not the same, so I'm going to stop and say it's not an arithmetic sequence. Here I have negative 3 minus 2, and I get negative 5. And I have negative 8 minus negative 3, and I get negative 5. And then negative 13 minus negative 8, I also get negative 5. Because I have the same difference throughout, I'm going to say yes, that this is an arithmetic sequence. And then lastly, I have 5/4 minus 1, and that's going to give me 1/4. And then 3/2 minus 5/4, and that's going to give me 1/4. And then I have 7/4 minus 3/2. That will also give me 1/4. Because I have a common difference that's the same, then I say yes, this is an arithmetic sequence. And if you notice, the ones that we had the same, we can see exactly where that common difference is going to go. It's always going to go in front of the n. The nth term of an arithmetic sequence has the form a sub n is equal to dn plus c, where d is our common difference, and in order for us to find c, we're going to take our first term and subtract it from our common difference. So if we look at this arithmetic sequence that's given, and this one is not given in your notes, right? We're going to find our common difference by taking the second term minus our first, and here we can see that our common difference is going to be 8 minus 2, which is 6. And then we're going to take our first term, which is 2. So to find the c, we would have to take 2 and subtract it from the common difference of 6, and that's negative 4. So when we put it together, we say a sub n is equal to 6n minus 4. This next example is also not in your notes. So let's look at this arithmetic sequence. So the first thing I would do is I would look for a common difference. And to find the common difference, I take the second term minus the first term. And here my common difference is 4. To find the c, what I'm going to do is take my first term, which is 2 here, and I'm going to subtract it from my common difference, which was 4. So here, 2 minus 4 is negative 2. So now I'm going to put them together for my a sub n is equaling dn plus c. So a sub n is equal to 4n minus 2. And that is my nth apparent term. In example 2, it says find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. So they're telling us that the d, or the common difference, is 3, and they're also telling us that our first term is 2, which is going to help us find the c. So here c is equal to our first term minus our common difference. So here I have 2 minus 3, which is negative 1. So now I'm going to put that together for a sub n is equal to my common difference plus my c. So a sub n is equal to 3n minus 1. And that right there is my formula. Example 3 is a great example of what you're going to see on your test. So it says the fourth term of an arithmetic sequence is 20, and the 13th term is 65. Write the first several terms of this sequence. So the first thing I'm going to do is I'm going to take my a sub 13, or my 13th term, and I'm going to set it equal to the fourth term that they told me about, and I'm going to add it with 9 times the common difference. And where I'm getting the number 9 from is by looking at how many terms are in between 13 and 4. So I'm taking the 13 and I'm taking the 4, and I'm looking for how many terms lie in between. Because there are 9 terms that lie in between, that's the number that's going to go in front of my common difference. So now all I need to do is replace what I know here. So I know that a sub 13 is 65, and I also know that a sub 4 is 20. And I'm going to add that with 9d, and I'm going to get d by itself to find the common difference. So I subtract 20, and I get 45, and that's equal to 9d, and then when I divide both sides by 9, I get d is equal to 5. So now that I know the common difference, what I can do is work backwards to figure out what my list of terms are. So if I know that my fourth term, right, a sub 4 is 20, and I know that my 13th term is 65, and I know that the common difference is 5, right? If I go to A13 and I get 65, then I know that it's going to keep on going up by 5, because that's what was my common difference, which means a sub 3, or my third term, would have to be 5 less than 20, which is 15, and my a sub 2 would have to be 5 less than that, which is 10. Finally, my a sub 1 would have to be 5 less than that, which is 5. So here are the first several terms of the sequence, and if I wanted to keep going, I could. So here, this is how I find my answer. If you know the nth term of an arithmetic sequence and you know the common difference of the sequence, you can find the n plus 1 term by using the recursive formula. A sub n plus 1 is equal to a sub n plus d. With this formula, you can find any term of an arithmetic sequence if you know the preceding term. It says if you substitute a sub 1 minus d for c in the formula a sub n is equal to dn plus c, the nth term of an arithmetic sequence has the alternative recursion formula a sub n is equal to d sub n plus a sub 1 minus d, which turns into a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Now, I don't usually use this formula, even though it is very direct. I have more of a tendency of using what we did before, finding the common difference and then finding the c, and then plugging in what I need to. But if you want to memorize this formula, you can. I'm going to show you in the next example how you can use both. Example 4 says that find the 7th term of the arithmetic sequence whose first 2 terms are 2 and 9. So the first way I'm going to show you is how we've been finding these arithmetic sequence all along. And then the second way, I'm going to apply the formula that we just saw on the previous slide. So let's find the common difference by taking the second term minus the first, and I get that this is 7. So now what I'm going to do is find the c, and the c is when we take the first term, which we know is 2 here, and we subtract it from the arithmetic sequence, which we just found to be 7. So I have the c is negative 5. So my equation or formula is a sub n is equal to d, which is 7, n plus c. So here's my equation. So now in order for me to find the 7th term, I'm going to replace everywhere I see an n with the number 7. So I have 7 times 7 minus 5. So I get that a sub 7 is going to equal 44. Now this is one way to do it, and this is the way that I typically do it. But the second way has us using the formula that they provided on the previous slide, where we can take a sub 7 and set it equal to our first term, which is 2, plus n minus 1, so our n is 7, minus 1 times the common difference, which is 7. So when I do this, I get a sub 7 is equal to 2 plus 6 times 7, which we know is 2 plus 42, and we get a sub 7 is equal to 44. So we get the same exact answer, and yes, it's less work, but I feel like the first one is really not that much work. Now we're going to look at the sum of a finite arithmetic sequence with n terms when n terms is given. Okay, so a finite means that it stops or it ends. So S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. So n over 2. So n is going to stand for how many terms are in the sequence. And then a sub 1 is our first term, and a sub n is going to be our last term. So n is the number of terms in the sequence. A sub 1 is the first term. That should be a T, right? First term. And then our a sub n is our last term of the sequence. So here, if we had an example of a finite arithmetic sequence like this, 5, 10, 15, 20, 25, 30, 35, 40, and so forth, what we could do is add up those list of numbers that are given, and we can also use our formula that's given. So the n, like I said, is the number of terms in the list. So here in this example, there are 10 numbers present. A sub 1 is our first term, which in this case is 5, and a sub 10 is our last term, which is our a sub n. So if I plug all my values in, I wind up getting 275 as the sum of my finite sequence. You're going to have to memorize this formula for the sum of finite arithmetic sequence for your test when you take it. So make sure that the formula up top here is what you're memorizing right here, okay, for your test. Example 5 asks us to find each sum. So in part A, we're given a list of terms, and they're already starting to add them together. So what we're going to do in part A is first let's label how many, or find out how many terms we have in the sequence. So if we count up how many numbers are listed here, you would see that we have 10 numbers listed here. We know that our first term is the number 1, and our last term, the 10th number in the sequence, is the number 19. So we can put this together for our formula that S sub n is equal to n over 2 times the first term plus the last term. So I have that S sub n, or S sub 10, we can fill that in. S sub 10 is equal to 10 over 2 times 1 plus 19. And when we simplify this all the way, we wind up getting that this sum is 100. Now for part B, they're not showing us the list, but they're telling us to find the sum between 1 and 100. So I know if I'm going between 1 and 100, I'm going to have 100 terms in the sequence. And I know that my first term is going to be the number 1, and my last term that I see here, right, because it's going to 100, is 100. So I have S sub n, so S of 100 is going to equal 100 over 2 times 1 plus 100. So when I add that together and then I multiply by 50, I wind up getting 5,050 is the sum of that list. Now just keep in mind that if my first term or my first number was 0 and we went to 100, then I know that instead of there being 100 terms in the sequence, it would have been 101. So just be aware that wherever it starts, be careful of how many terms you have in between. The last formula that you have to memorize from this section that you will use on your test is for the sum of the first n terms of an infinite sequence. So whenever it's infinite, it means it continues to go on. And what we're going to say is that we're using S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. Okay, so we're going to use the same formula we just memorized before for the finite, which is nice because it's less you have to memorize. Example 6, find the 150th partial sum of the arithmetic sequence 5, 16, 27, 38, 49, and so forth. So if I'm finding the sum, what I need is not only the first term, which is given in the list, but the last term. So I'm going to have to find my formula, or nth term of the sequence, in order for me to find the 150th term. So let's first list what our first term is, which is 5. And then my common difference is going to be 16 minus 5, which is 11. Now I'm going to find the c, and after I find the c, I'm going to put it in my formula to find my equation. So I know that the c is found by taking the first term minus the common difference. So I have 5 minus 11, which is going to be negative 6. Let me put that together and say that a sub n is equal to the common difference, which is 11, n plus c, which in this case is minus 6. So now that I have this, I can find the 150th term to use in my formula. So I have 11 times 150 minus 6. And this winds up being 1,644. So now that I know this, I can use the S sub n is equal to the number of terms in the sequence over 2 times the first term plus the last term in the sequence. So I have 150 terms in this sequence, and I'm going to divide it by 2, and I'm going to multiply it by the first term, which I know is 5, plus the last term I just found to be 1,644. And when I simplify this all the way, I wind up getting 123,675 as my sum of terms. Example 7, an auditorium has 20 rows of seats. There are 20 seats in the first row, 21 seats in the second row, 22 seats in the third row, and so on. How many seats are there in all 20 rows? So this would be my sum. So the first thing I'm going to do is I'm going to say that my first term of my sequence is 20 because there are 20 seats in that first row. Now I was given my second term, which was 21 seats. So I can use this information to find my common difference, which is going to be 21 minus 20, and that's going to be 1. So now what I'm going to do is I'm going to find my c so that I have an equation for the 20th row. So here I have c is equal to my first term, which is 20, minus my common difference, so I get 19. My equation is going to be a sub n is equal to 1 times n plus 19. With this information, I can find the 20th row and how many seats are in that 20th row so that I can find the sum. So I'm going to say a sub 20 is equal to 20 plus 19. So the last term of the sequence is 39. So now that I know that, I can say that S sub 20, because there are 20 rows, is equal to 20 over 2 times the first term, which is 20, plus the last term, which is 39. This simplifies to be 590 seats in the auditorium. And our last example, example 8, says a small business sells $10,000 worth of sports memorabilia during its first year. The owner of the business has set a goal of increasing annual sales by $7,500 each year for 19 years. Assuming that the goal is met, find the total sales during the first 20 years this business is in operation. So again, we're going to go through the same procedure we have been for the previous problems. The first term we know is going to be $10,000. Our common difference is going to be what they told us each year the person wants to raise. So 7,500. Now we're going to find what our C is by taking 10,000 and subtracting it from 7,500. We get that our C is 2,500. And we can use this to find our equation that A sub n is equal to our common difference, 7,500n plus 2,500. Now with this information, I can find the last term of the sequence, which is the 20th year of operation. So I'm going to say A sub 20 is equal to 7,500 times 20 plus 2,500. And that winds up being 152,500. I'm now going to use that for my sum formula. So there are 20 terms in the sequence because there are 20 years. So I have 20 over 2 times the quantity, and I'm going to have my first term, which is 10,000, plus my last term, which I just found to be 152,500. And when I simplify this, I wind up getting $1,625,000 is how much it's going to earn.